Under 8.9, extending the idea of the expected value of x and the variance of x to deal with the expected value and variance of a function of x. On page 165, let us understand the 5 statements together. And number 1, if x is a random variable, then the value of x is a number determined by an experiment. That already we know. Statement number 2, each function of a random variable has a probability distribution that you can derive from the probability distribution of x. Of course, we have outlined the probabilities of each and every event, and we have been able to come up with the sample space and the table of the probability of individual events. Number 3, and this is now where we need to start being keen. We need to be keen here. A general rule relating expected value of x, and expected value of ax plus b, where a and b are constants, is of course the general rule. Now, the expected value of ax plus b is given by a multiplied by the expected value of the expected value of x plus b. That one we are coming to explain. In the same way, the variance of x, and the variance of ax plus b are related by the rule that is how they relate. This is how the variance of ax plus b is given by a squared multiplied by the variance of x. Now, I want to say something further on the variance of x and how they relate with a squared times the variance of x. You can see we have not featured b anywhere on the right hand side. The variance is a measure of spread. The variance is a measure of spread relative to the mean, so adding a constant value to all the values of x will not affect this measure of spread. Hence, the b does not change the variance. Now, variance being a measure of spread, if we keep adding b to each and every value of x, it doesn't really change the variance. It only shifts the variance from one position to the other. So, b, adding any constants does not affect the variance. And that is why we have left out the b on the right hand side. But you can see there is a squared here. But a squared is understandable. If you remember that, of course, if you remember that the variance of x is given by ex squared minus ex squared. Of course, now, so if each value of x is multiplied by the value of a, the variance will be multiplied by the square. Of course, the reason why a squared comes over here is because initially we understood that the expected value of x squared minus the expected value of x, both of which are squared, then there is no question that a squared comes and takes up that position. Fine. I wish that we can go to example 13. But even before we go to example 13, I think this one is just important that all of us understand and highlight this. So if you're taking note under this subtopic, make sure you have this information somewhere at the right side of your book. Okay?